So if you remember the program that we were doing, we had this pow, we had this fact, so all these functions we had. So we were calculating this factorial of power I to the power of I. So the program that was basically being done was 1 to the power of 1 and the factorial of that. You can understand, 1 to the power of 1 factorial of that, then 2 square is 4 factorial. So 1 factorial plus 4 factorial plus 27 factorial. Why? Because 3 to the power of 3 factorial. That was the program we were doing. So fact of power I to the power of I, that is I and I were passed. Now next program that we will do, let us have this power and fact function as written, let it be there. The program that we can do is somewhat like this, maybe 1 factorial, please see this, 1 factorial to the power of 0 factorial. So you take this 1 factorial is done first, then to the power of 0 factorial, 1 factorial to the power of 0 factorial, that can be done, plus 2 factorial to the power of 1 factorial. I think you understand this, 2 factorial to the power of 1 factorial. Then you continue like this, plus the next number should be, the next term should be 3 factorial to the power of 2 factorial. So in this way, if I continue and the n is entered by the user, then definitely the last term or the last term of this expression should be n to the power of, n to the power of, n factorial, n factorial to the power of n minus 1 factorial. Please understand, is not it so? N factorial to the power of n minus 1 factorial. This is the thing we need to do. Now see, the factorial function is already written, the power function is already written. I had shown you the factorial function is receiving long int and also returning long int, so that you can deal with bigger numbers. Similar with pow. Now if I have to now write this program, also this part is there, that the sum can be taken as long int, because power, factorial, all these are after all returning long integers. So sum will be adding them. So long int is quite acceptable. Now I will ask for the n from the user. I will scan n from the user. Then how to continue? For I equal to 1, sum equal to 0, I less than equal to n, I plus plus. So I am continuing from 1 to n. See, this is 1. So from 1 I am starting, I am continuing up to n. So remember, in the for loop, when it is 1, I is 1, I need 1 factorial to the power of 0 factorial. When I is 2, I need 2 factorial to the power of 1 factorial. When I is 3, I need 3 factorial to the power of 2 factorial. And so on, I need n factorial to the power of n minus 1 factorial. I missed it out, sorry. N factorial to the power of n minus 1 factorial. So when I is 1, I need 1 factorial to the power of 0 factorial. When I is 2, I need 2 factorial to the power of 1 factorial. When I is 3, I need 3 factorial to the power of 2 factorial. So when I is 1, what do I need? When when it is I generally, what do I need? I factorial to the power of I minus 1 factorial. Is not it so? So you can think like this, that over here, when this loop is done, this sum is actually, how will it be calculated? I factorial to the power of, if I write like this, though this is not allowed, I am showing this, I minus 1 factorial. Please understand, is not it so? I need I factorial to the power of I minus 1 factorial, and that added to sum. Please understand this, I enters with 1, When I is 1, you need 1 factorial to the power of 0 factorial to be added to sum. When I is 2, you need 2 factorial to the power of 1 factorial to be added to sum. When I is 3, you need 3 factorial to the power of 2 factorial to be added to sum. In this way, when I is 4, you need 4 factorial to the power of 3 factorial to be added to sum. So this is what you want. So when I is n at the end, what you are doing, n factorial to the power of n minus 1 factorial, and it cannot enter with a value of I equal to n plus 1, means the last term is n factorial to the power of n minus 1 factorial. Question is how this is done. This is not allowed. I factorial cannot be written like this. So definitely this part, only consider this part. What is this part? This is fact of I. You have got the fact function with you. This is fact of I. What is this going to return? It is going to return long. Isn't it so? I is integer. You are sending it to a long, acceptable. You can send always an integer can be received in long. There is no problem with that. But it is going to return long. So fact of I, what is this part? This part it is. Now what if I need this now? Please see this, I minus 1 factorial I need. So you can understand I need fact I firstly. I also need fact of I minus 1. Please understand, I also need fact of I minus 1. Now what I need to do is fact I to the power of fact I minus 1. But this to the power is not allowed. This symbol is not there. So what is this symbol? 2 to the power of 3 is written using the function pow 2 comma 3. So definitely fact I to the power of fact I minus 1 can be written as pow of fact I and fact I minus 1. See how it is happening. Pow has to receive 2 parameters. So definitely you are sending 2 arguments from here, fact I and fact I minus 1. And the 2 parameters that it is receiving are fact I's result and fact I minus 1 result. See how it is happening. Firstly, fact is being called with I. The answer returns exactly over here. Isn't it so? Then fact I minus 1 is being called. The answer returns exactly over here. Then fact I contains the answer fact I minus 1, this position contains the answer fact I minus 1. What is pow doing? Pow is just sending those numbers to the pow function. Remember, fact I and fact I minus 1 returns long and pow receives long. There is no problem if you send int and receive it in long. But sending long and receiving in int should not be done. Then the number can be changed to a smaller number, because big number cannot be received in a small number. Isn't it so? So this is how it is done. See, pow is receiving. So in this program you see what is happening. What is happening is this pow function has to receive 2 parameters. Those 2 parameters it is receiving. Now to send the 2 parameters to pow, firstly these 2 parameters are also calling a function in order to get those values. So this is allowed nested function in a big way. It is getting nested fact I once, then fact I minus 1, and then pow is being called. So you can easily run this program now and check whether it is running smoothly or not. The program is 1 factorial to the power of 0 factorial. So if I enter only 1, the answer should be 1 factorial 1, 0 factorial is also 1, 1 to the power of 1 is 1. Is not it so? Please understand this. I will just comment out this portion before running this piece of code. I comment out this portion before running this piece of code. Now 1 factorial, if I enter 1, then this answer should be only 1. 1 factorial is 1, 0 factorial is 1, 1 to the power of 1 is 1. Now look at this term, 2 factorial to the power of 1 factorial. 2 factorial is 2, 1 factorial is 1. So this is 2 to the power of 1, which is 2. So if you enter instead of 1, if you enter 1, your output should be 1. If you enter 2, the output should be 1 plus 2, 3. If you enter 3, then what? See, the third term is 3 factorial. 3 factorial is how much? 6. 3 into 2 is 6. So 3 factorial is 6. What is 2 factorial? 2. 2 factorial is 2. 3 factorial is 6. So this is 6 to the power of 2. 6 to the power of 2 is 36. Is not it so? So what should be the result? The result should be 1 plus 2 plus 36, that is 3 plus 36. If you enter 3, the answer should be 39. What if you enter 4? What if you enter 4? 4 is this term. This term is 4 factorial. 4 factorial is 24. To the power of 3 factorial, 6. 24 to the power of 6. That you will have to calculate and see. What is 24 to the power of 6 and see? Now let me run it with these numbers, smaller numbers. 1, it should show 1. If you run it with 2, it should show 3. Yes, 3. If you run it with 3, it should show 39. Absolutely fine. If you run it with 4, then that extra big number is being added. See, 1911030015. You can check out 4 factorial to the power of 3 factorial. That is, 4 factorial is 24, 3 factorial is 6. 24 to the power of 6, what it is, and then add it with then 1 plus 2 plus 36, that is, and check out what is the number. You will find this is the number. So the computer helps you in computing bigger numbers with long int. One thing I will do before ending this is have a look at this. See, calling a function is often, it is good, but then often calling a function can lead to bad results or bigger results. That is, it may take a long time. Say when you are calling fact I, say you need to calculate, please check this, what I want to point out. Say you want to calculate 6 to the power of 5. So, or not 6 to the power of 5, 6 factorial to the power of 5 factorial. If you enter 6 as n, then definitely 6 factorial to the power of 5 factorial also have to be computed as the last expression. Now check this, 6 factorial to the power of 5 factorial. When you call this fact I, you are sending 6 to it. How is 6 factorial being computed in this fact function? How is 6 factorial being computed? Firstly 2 is multiplied, then 3 is multiplied, then 4 is multiplied, then 5 is multiplied, then 6 is multiplied. Then you get this result product and then you return it. In this way, you are calculating 6 factorial. Then when you come back, you are again calling fact I minus 1, that is, you are calling with 5 factorial. So again it goes over here, receives 5 over here. To calculate 5 factorial, it again starts from 2. It multiplies with 2, it multiplies with 3, it multiplies with 4, it multiplies with 5. Now multiplication of 5, if it is 5 factorial, if it is computed once, then for computing 6 factorial, you only need to multiply only 6 with it. But here you are again starting from 2, you are multiplying 2, then 3, then 4, then 5, then 6. Remember the case, suppose you have to calculate 100 to the power of 99. Possibility? Always a possibility. Say 100 factorial, if you need to now compute 100 factorial to the power of 99 factorial. Firstly, you pass this 100 to fact. When you pass this 100 to fact, it receives, in n it receives how much? It receives 100. So it starts 100 being 1 being multiplied, 2 being multiplied, 3 being not 1, 2 being multiplied, 3 being multiplied, 4 being multiplied, 5 being multiplied, 6 being multiplied. This loop iterates from 2 to 100. And every time 2, 3, 4, 5 and so on up to 100 is being multiplied with product. Now next time you are again calling this fact 99. What is happening as a result? When this fact 99 is being called, again you are starting from 2. So you are multiplying 2, you are multiplying 3, you are multiplying 4, you are multiplying 5 and so on. You are multiplying up to 99. Now that means that you are multiplying up to 100. You are multiplying up to 100 one time, again you are multiplying up to 99. The same multiplication happens. Suppose you are multiplying only up to 99. 99 factorial you have obtained. Then you only multiply 100, you get 100 factorial. You don't need to start the loop yet again. So that way, this program could have been made easier by avoiding calling of nested or calling of functions like this or nested functions like this. How? You take a variable called, say, x, any variable x, and then you do, when you are over here I, when you are over here I, you do call with I minus 1. Say I is 100. If I is 100, you need to calculate 100 factorial to the power of 99 factorial. So you are calling fact 99. You have got the result in x. Is not it so? Now you know that when you now need to calculate sum, this calling of fact I and fact I minus 1 can be avoided, because fact I minus 1, it is already there in x. This is there in x. How to calculate fact I? Fact I is nothing but I into x. Please understand this. X is fact I minus 1. What is x? X is factorial of I minus 1. If you multiply I with it, you get factorial I. And factorial I minus 1 is already there in x. So calling this function only once does your job. That function loop iteration does not need to be done twice. You can definitely do it, but doing it is actually you're doing it twice. You're iterating a loop from 2 to 99 2 times. So it is not needed. Suppose 99 is needed, only iterate the loop from 2 to 99 once, get the result in x. Next time you don't call the function, you just multiply I, that is multiply 100 with 99 factorial and get the 100 factorial over here. And here you only use the 99 factorial. So this way the program can also be done. You just end the for loop over here. You have used 2 statements, so only use the over here, only close the bracket over here. 2 statements have been used. You can run the program and see. One error. Why one error? X was not declared. Is not so? We did not declare x. So x is what? X is receiving the result of fact function. What does fact function return? Long int. So x must be defined as long int. So over here, besides sum, you is a x as a long int. You can run the program now and check what happens. You can use that 1 to get 1. You can use the 2 to get 3 again. You can use the 3 to get 39 again. And you can use the 4 to have that big number again. But this program will run faster than the previous program. However, you have seen that in a nested function, within one function, 2 functions can also be called. In fact, multiple functions can also be called. That is what you have learned. We'll do more programs with function. However, we take a bit of break over here. We'll come back with the next program soon. Thank you so much.